day, my amazing scientists. It's your favorite sensei here again, Sensei Mohau, and I hope you all are having a good day. On this video, we are gonna be dealing with a past paper question of arithmetic sequences, sigma notation, evaluating sigma notation, and finding the number of the upper limit in a question. So if you have not yet subscribed to the channel, please do the right thing. And also, please share this video as much as you can to your friends, to your cousins, to your neighbors, and tell them that Sensei is back with a fresh lesson, and we are mastering arithmetic sequences, geometric sequences, and sigma notation. So without any further ado, let's dig in and start working. So question 1 says, evaluate E at 70, which means our upper limit is 70, our lower limit is 4, and it's Tn minus 4. Let me change this. So it's 70 at the top, which means we know that the terms in the sequence. How do we find how many terms we have in the sequence? We will take our upper limit minus our lower limit, then we add with 1. Then we're gonna find the numbers of the terms in the sequence. We know that we have 67 terms in the sequence. So now here we are given a number that we can use to find the sequences. So sequence 2 and 3. So now we need to find the first 3 terms on the sequence so that we can use them to find our D, which is the constant difference, and then we can try to find even the last number. Since right now, remember that sigma means the sum, so we can try to find the sum of this arithmetic sequence, since this one is an arithmetic sequence. But we can still check if whether it's an arithmetic sequence or not by trying to find the first 3 terms and finding the constant difference order sheet. Let's do that. So it's T. So we know that, remember, now that like we did in the previous lesson, whenever our n, our lower limit is 4, which means the first term will be the 4th, will have n of 4. So the 5th term will have n of 5. The 6th term will have n of 6. Ne? Please remember that. If you don't understand this thing, let me try to explain it. Besides, in the previous video, I explained it fully. I was dealing with it. I was focusing on the full lesson. I was focusing on it. So you can try to rephrase and watch the previous video. Or remember, if our n here it's 1, which means our n starts at 1. Let's make this table like we used to work with these tables in grade 9. It's n, and this is the term. Ne? So it's n of 1, n of 2, n of 3. Ne? So whenever our n is 4, which means the lower limit up until 70, let me make this thing. I just make 70. Ne? Shows that it goes from 1 till 70. But now, if our lower limit is n, ne? The rule, remember, it's 2n minus 4. Ne? But now, if the lower limit is 4, which means 4 will be the first term. N of 4 will be the first term. 5, 6, 7, and it goes up until 70. Please keep that in mind. Ne? Keep that in mind. Minus 1. Our answer here will be 8 minus 1, which is 7. Then 2 of 5 minus 1 is 9. Then 2 of 6 minus 1 is 11. So you can see that it's 7, 9, and 11. So it's very important for us to find the first 3 terms in the sequence, because we can use this to find, let me erase this, we can use this to deal with any other question that they may require us to do. So we found the first 3 terms. We know that the constant difference is 2 because it adds with 2. Yeah? And then it's gonna be the sum of, so I'm gonna use 2 equations right now. Yeah? So the sum, I'm gonna firstly use this one, and then I'm gonna use the second one. Yeah? Why am I using this one? Remember that since we know that the upper limit is 70, we know that if we find Tn of T of 70, and where there is n we put 70, we will find the last term in the sequence, which is equals to 139, because we have this upper limit. If we don't have an upper limit, so we cannot use this equation. Remember, so the sum of 67 terms is equals to 67 over 2, a, the first time is 7, plus 139. Let me use a calculator quick. So it's 7 minus 7 added by this is gonna be 146. Then 146 divide, okay. Then, okay. 67 divide by 2 multiply by 146. Our answer is 4,891. This is how we do it, using the last term in the sequence, because we know that the upper limit is 70. Yeah? So you may use the other one. Let's try to use it. Erase this. Yeah? So still remember, it's Sn equals to n over 2 2a plus n minus 1 d. 57 over 2, it's 2 of 7 plus 67, remember, 67 times minus 1 and 2 here. Yeah? So you can punch everything here in the calculator, it will still give you the same answer. Let's just try it. Here it's going to be 14 plus 66 times 2 is 132 plus 14 is 146. Then this thing multiply by that, it's still gonna give us the same. Still gonna give us the same answer. 4,891. So this is how we basically do this type of question. Remember, why did we use, that's why it's 3 marks. Né? This question is just 3 marks, question 1. Why? Because of the, just know, for you are given the upper limit, we are given the lower limit. You can find the first term in the sequence, second and third, and also you can, they have given you an equation that you can use. Né? So definitely you can just use either one of these equations using the information that you have given here, they're giving you here, and then you just score easy 3 marks just like that. So remember, né? The first thing you need to do here, check if you are given the upper limit and the lower limit. If you're not given the upper limit, then you need to use another alternative method. Probably if they didn't give you the upper limit, they're gonna give you the sum. Let's say probably it's like this is equals to 4891. Ne? So if they didn't give you this thing, they are gonna give you this thing, so that you can solve for it like this. Let's say we put it here, and let's say this is gonna be like we're solving for n. Let's say here it's n here. You're solving for n given the sum of this arithmetic sequence. So hope you all understand. let's move to the next question.
Question 2 says, what is the value of m for which we are given this sigma notation. We know that our lower limit is 1, our upper limit we don't know it, which means we don't know the last term of the sequence, which means we don't know the last term of the sequence, we don't know it. But we are given that this geometric sequence is equals to 65. So we know whenever we have R and we know that the sum, we can find our m by using this equation, R minus 1. Why? Because we know that if we equate everything here, we're just gonna be solving for the term of the sum of the term, the sum of the term. This term is a guy that will equate everything to the 65. So it's 3 to the power n minus 1 over r minus 1. So let me just use m here, or k, no matter whatever we may use. So our r, it's 3 here. So from here, since we're solving for this, we take this to the other side, multiplying by 8. It's 65 multiplied by 2, which will give us 130. Which will give us 130. And then we will be left with 130 equals to 5, 3 to the power m, or 3 to the power k minus 1. So we divide again by 5. So 130 divided by 5. Then here on this side, we'll be left with 3k minus 1. Then our 1 will go to the other side. 130 divided by 5, it's 26. 26. So 26 plus 1 equals to 3 to the power k. So now 27 to the power base 3, we know it's 3 to the power 3. And we know that k, or m, is equals to 3. Let me just say m equals to that k equals to 3. So we know that the sum of the first 3 terms in this sequence is equals to 65. So let me just change it here. Get a k, k here. Also m. Sorry. So remember, here we were given the value. So we are given the sum of the sequence. So we were given the value of the sequence. So we, using this information, we knowing that the sum of everything is equals to, knowing that the sum of this geometric sequence is equals to 65, we know that our a is 3. We can find our m, or the upper limit, using this equation. So let's move to the next question. So let's go to the last question. It says, consider the sequence 1 over 2, 4, 1 over 4, 7, 1 over 8, 10. Okay, seems like here, our first, the odd numbers here, like 1, 3, 7, 1, 3, 5, that's terms like 1, 3, 5, the odd numbers, and the even numbers 2, 4, 6, 8 are in 2 ways. This 1 over 2, you can see by 1 over 2, 1 over 4, that this is multiplied by half. So this is a geometric sequence, ne? And this is an arithmetic sequence because we can see it's 4 and 7, which means we added by 3, 3, 3, ne? So the okay, if the pattern continues the same, we write down the next 2 terms in the sequence. So we know that it's 1, 2, 3, 4, 5, 6. So the 7th one will be odd number, which will be 1 over 16. How did we find it? Remember our R. So here, ne? Remember that it was 1 over 2. We multiplied by half. It became 1 over 4. We multiplied this by half. Ne? It became 1 over 8. So you can see that we're multiplying by half to get the next one, which means our half is our ratio. So 1 over 8 multiplied by half is 1 over 16. And this one we add by 3, which will give us 13. So this is the first term. So remember, here, you will notice whenever you see what if you do it like 1, 2, 3, 4, it won't make sense because from 1 till 4, we multiplied by 8. Then all of a sudden, 1 over 4 and 7. You see what it doesn't make sense. Note that this is the combined geometric and arithmetic sequence in one like sequence. Ne? So just keep that in mind. So how do we calculate the number, the first 25 times in the sequence? We know that 1, 3, 5, 7, it's the first 25 part, first 25, it's geometric sequence, ne? And the first, okay, so the last or the second 25, it's the arithmetic. So we can find the number, the first 50 terms by finding the first 25, the sum of the first 25 terms of the geometric. So we're gonna do like this. First 25 terms of the geometric. We're using this equation because remember that R is half. So it's a converging 1 over R, ne? So it's 1 over 2. Remember, it's in this sequence. In this sequence, it's 1 over 4. We're looking only at this number still, not the other ones. So our half is 1 over 2. So 1 over 2 and 1 minus R to the power n, it's half to the power 25, then close bracket, and it's 1 minus half, the sum of the first 25 terms. Let's use a calculator quick and find the answer. Then we do the sum of the first 25 arithmetic terms. Then we combine the answers. Then that's how we are going to do this question. So answer is 0.999999, which means that it limits us to just 1. So you can just say the answer is 1, and the sum of the first 25. Let me just erase this. The first or the second 25 arithmetic sequences. It's gonna be sum of first 25 times. Let's just use this equation. 25. Okay, let me just write n over 2. Let me just not rush. 2a plus n minus 1 d. So here we have 25 over 2 into 4. Remember that we're looking only at the even numbers here, which is the arithmetic sequence. The first term is 4, second term is 7, third term is 10, plus 25 minus 1 into 3, So let's use a calculator quickly here. So answer here we know is 25 over 2, which here will be 8 plus 24 times 3, Our answer here is 1000, So the sum of the first 50 terms is basically us adding 25 and 25, which our answer will be 1001. So this is how we do it. Easy, ne? Easy peasy. So remember, in terms of such kind of questions, just check whenever you are given something that does, an equation that doesn't, sequence that doesn't really make sense, know that they divided the other half to be geometric, other half to be arithmetic. So I really had a great time with you, my amazing scientists, and I hope you all did too. If you have not yet subscribed, please press that subscribe button now, right now. And don't forget to share the video as much as you can to your friends, to your neighbors, to your buddies at school. Tell them that the sensei is back with a fresh lesson, and hope you all enjoy the rest of your day. And I'll see you in the next video. Enjoy your have a lovely day. Bye bye.